Here we have a problem on permutation. Okay, let's go to the question. Compute the sum of 4-digit numbers which can be formed with the 4 digits 1, 3, 5, 7 if each digit is used only once in each arrangement. Okay, let me consider the given 4 digits 1, 3, 5, 7. I can form a 4-digit number with these 4 digits, that is 1357. In this way, I can form different 4-digit numbers with these digits like 1375 or 1537 or 1573. So I can keep on writing the 4-digit numbers with these digits, and also there is a condition that each digit is used only once in each arrangement. So let me consider the first arrangement over here. So the digit 1 is used only once, the digit 3 is used only once, and the same we have for 5 and 7 as well. That is, this condition says, for example, let me write 1355. So this particular digit 5 is used twice, but we should not do it. So this 4-digit number breaches the condition over here, so we cannot accept this one. So that is, we have to form 4-digit numbers with these 4 digits, and each digit has to be used only once in each arrangement. And then we have to add all those numbers according to the instruction we have over here. So for that, first we have to find how many 4-digit numbers can be formed with these 4 digits 1, 3, 5, 7 with the condition that each digit is used only once in each arrangement. For that, let me create 4 blanks, 1, 2, 3, 4. So the first blank here it's for ones place, and this one is for tens place, and here it's for 100ths place, and this is for thousands place. Okay, now let me consider the thousands place. So how many options do we have for thousands place? So whether I can take 1 or 3 or 5 or 7, I can consider any of these 4 digits for the thousands place. So we have 4 options for thousands place. Even though we have 4 options for thousands place, this this blank, that is a thousands place, can be filled with only one of these 4 digits. Anyway, so once this place is filled with one of these 4 digits, the same digit cannot be considered for the remaining places. So now we have 4 options, and one of these 4 digits is used in thousands places. Now, how many options do we have for hundreds place? We have only 3 digits, because one of these 4 digits is used over here. So now we are left with 3 digits. That is, we have 3 options for hundreds place. So even though we have 3 options for 100 place, so this place can be filled with only one of the remaining 3 digits. Now we are left with 2 digits. Now how many options we have for the tens place? We have only 2 options. So even though we have 2 options, this place can be filled with only one of the 2 remaining digits. Now we are left with only 1 digit. So we have only 1 option for the first place. Now we have to multiply the number of options I have written over here. 4 times 2 is 12, 12 times 2 is 24, 24 times 1 is 24. That is, I'll be able to form 24 4-digit numbers with these 4 digits. And also this condition is also met, that is, each digit will be used only once in each arrangement. So is it possible to display all the 24 4-digit numbers which are formed with these digits and also add them? No, it's not possible. Anyways, it's possible, but it will be time consuming. But we must find some shortcut to get answer for this question. So for that, what I'm going to do is, I'm going to consider the 3 digits 1, 2, 3. Okay, the same condition. Let me take for this one also. That is, I have to form 3-digit numbers with these 3 digits. Each digit has to be used only once in each arrangement. So let me create 3 blanks: ones place, tens place, and hundreds place. How many options do we have for hundreds place? 3 options. That is, we can use any of these 3 digits. 3. So once one of the digits is used over here, we'll have only 2 options for tens place. One of them will be used, we'll have only 1 option. When we multiply them, 3 times 2 is 6, 6 times 1 is 6. That is, I'll be able to form 6 3-digit numbers using these 3 digits, and each digit will be used only once in each arrangement. Let me write those 6 3-digit numbers. In this case, I can display. But in 4-digit numbers, it's a bit difficult because we have to write 24 4-digit numbers. But in this case, we just get only 6 3-digit numbers. Let me display. That is, the first 3-digit number is 123. The second one, 123. The next one is 132. The next one is 213. The next one is 231. The next one is 312. The next one is 321. So these are the 6 3-digit numbers which have been formed with these 3 digits. When you look at each arrangement, each digit is used only once. Okay, now let's look at so this one. This is actually ones place, and this is tens place, and this is hundreds place. When I consider the numbers over here in tens place, each of the given three digits is comes twice. That is, if you consider the first digit one, it comes twice. And when I consider the second digit two, that one also comes twice, and this three also comes twice. Okay, so when I consider the tens place, the same thing is happening. That is, we have the first digit one two times, the second digit two times, and three two times. The same thing is happening hundreds place as well. So this is ones place, and this is tens place, and this is hundreds place. So in each place, each digit is repeated two times. Okay, since I'm able to display all the six three-digit numbers, I can see how many times each digit is repeated in ones place and tens place and threes place. Without displaying the numbers, how do we have to know? So each digit is repeated how many times in ones place, tens place, hundreds place. For that, let's consider the total number of three-digit numbers formed. So there are six three-digit numbers formed over here. It has to be divided by the number of digits given. So 6 divided by 3 is 2. So that is, each digit is repeated two times in ones place, tens place, hundreds place. The same thing. Okay, now let's add all these numbers in ones place. What do I get? So 3 positive 2 is 5, 5 positive 3 is 8, 8 positive 1 is 9, 9 positive 2 is 11, 11 positive 1 is 12. Instead of adding all these numbers in ones place, I'm going to follow another trick. Because it's all of them displayed, we can add them manually. But instead of that, without displaying all the numbers, so let's see how can we get the total of all these numbers, that is sum of all the numbers in ones place. For that, we have to add all the three digits 1, 2, and 3. It has to be multiplied by 2. I multiply this sum by 2 because each digit is repeated two times over here. So 1 positive 2 is 3, 3 positive 3 is 6, and 2 times 6 is equal to 12. Now we get the same total 12 over here. What if I add the digits, the numbers in tens place? I'll be getting the same total 12 because each digit is repeated two times. What if I add the numbers in hundreds place? Again, the same total, I'll be getting 12. So in ones place, I'm getting the total 12. In tens place, I'm getting the total 12. In hundred place also, I'm getting the same total 12. Since I'm getting a total, the sum of the numbers in ones place as 12, I multiply this 12 by 1. I am getting 12 as a result. Since I'm getting the sum of numbers in tens place as 12, I multiply 12 by 10. 12 times 10 is 120. Since I'm getting the sum of numbers as 12 in hundreds place, I multiply 12 by 100. Then I'm getting 1200. Now let me add them. 1 positive 2 is 3. 1 positive 2 is 3. 1332. So if I add all these six three-digit numbers over here, I'll be getting the same total 1332. So you can cross check by adding all these three-digit numbers and you can verify whether we get the same total, that is 1332 over here. Since we have displayed, we can add them, but without any display of all the numbers. So this is the idea to get to compute the sum of the numbers formed. Now I'm going to apply the same idea. So in our problem, that is 1357, already we know that there are 24 four-digit numbers formed using these digits, and in each of those 24 four-digit numbers, each digit will be used only once in each arrangement. Okay, now so we'll have thousands place and hundreds place and tens place and ones place. Okay, in ones place, so each of these four digits is repeated how many times? For that, we have to divide the total number of numbers formed 24 by the number of digits given, that is 4, that is equals to 6. Each digit is repeated 6 times. That is 1 is repeated 6 times, 3 is repeated 6 times, 5 is repeated 6 times, 7 is repeated 6 times. When we add them, we get 24. That is, in the 24 four-digit numbers formed in ones place, so each of these four digits repeated 6 times. Okay, in those 24 four-digit numbers, to get the sum of all the numbers in ones place, we have to add all the given four digits and multiply it by 6. So 1 positive, 3 positive, 5 positive, 7, and this sum has to be multiplied by 6. 1 positive 3 is 4, 4 positive 5, 9, 9 positive 7, 16, that is 6 times 16, that is equal to 96. That is the sum of all numbers in ones place in the 24 four-digit numbers is 96. So the same sum will be getting in tens place as well, hundreds place as well, and thousands place as well, because in all the places the same four-digit numbers will be repeated 6 times. Okay, since we get the sum of the numbers in ones place as 96, So this 96 has to be multiplied by 1. So the result is just 96. Now let's consider this one. That is, we get the sum 96 in tens place. So this 96 has to be multiplied by 10. Then I'm getting 960 over here. And we get 96 as a sum of all the numbers in hundreds place. So we have to multiply this 96 by 100. Then I'm getting 9,600. Okay, here we get the sum of all numbers in thousands place as also 96. So 96 has to be multiplied by 1000. Let me do it. So when I do so, I am getting 96,000. Let me write the stuff over here. Now let's add them all. So here 9 positive 6 is 15, carry over 1. So 9 positive 1 is 10, 10 positive 6 is 16, carry over 1, 9 positive 1 is 10, 10 positive 6 is 16, carry over 1, 9 positive 1 is 10. So I am getting the sum 106,656. That is the sum of all 4-digit numbers which can be formed with the digits 1, 3, 5, 7 is 106,656. And also here each digit is used only once in each arrangement. So the answer for this question is 106,656.